Now, what would be a suggestion as to what might happen next year?
Then that negative enolate will attack the terminal carbon of the alkene.
That's right, the beta carbon here. Good. Why is this beta carbon electrophilic?
Through resonance.
There's another resonance structure where we can show this has a positive charge. We talked about that last time. So let's draw the mechanism for what happens there. You don't want to show the hidden hydrogen here? Okay, good.
Oh, here.
Since it's an aldehyde. All right. Now, I think you drew a mechanism that's maybe a little bit more complicated than you need, but that's fine. When we attack this beta carbon here, you have a choice. You can draw the resonance form where the negative charge is on this carbon, or like your instructor might do, you can put the negative charge on this oxygen. I prefer to put it on this carbon because this is the one that ultimately ends up protonated. I think the way you did it is you first protonated the oxygen and then you did tautomerization. We talked about that last time. So whichever way is fine, as long as you get this product over here. But ultimately, this is going back to being an aldehyde. So for me, it's simpler to just draw the resonance forms that keep it as an aldehyde all along. But I think the way you drew it was fine. In fact, that's the way instructors usually write it. Okay, so what type of mechanism is this? There's a name for this type of attack on this alpha-beta unsaturated aldehyde.
1,4.
Yeah, this is called 1,4. That's a little bit confusing, but we talked about why it's called 1,4 last time. Although, again, really, the only things that really happened is that the alpha carbon attacked this carbon, and this gained a proton. Ultimately, that's what happened. These were the only two carbons that really changed, ultimately. Now, another name for that is conjugate addition. Now, another name for it when the attacker is an enolate is a Michael addition, and that's a term that you might have heard in class. So, Michael addition is a 1,4 addition where the nucleophile is an enolate. Michael addition is a 1,4 addition where the nucleophile is an enolate. There's other nucleophiles that could have attacked here too. I don't think those are usually called Michael additions, but if the attacker is an enolate, that would give us a 1,4. So last time we talked about 1,4 additions, but we didn't do any Michael additions. We didn't use any enolates as the attacker. All right, then that would give us this product here. So one of the most important things we learned here is if you've got a 1,3 dicarbonyl, it's the middle carbon that's especially acidic because of extra resonance. All right, so that's one step to understanding the Robinson annulation, which is this Michael addition reaction. Robinson annulation is pretty complicated because it's multiple reactions, but part of it is this Michael addition. Okay? All right. draw the mechanism for this reaction. Oh, I don't really want to get into that. We decided we wouldn't get to that yet, so let's draw this mechanism.
Without the CH thing?
Yeah, without the
So it really
CH.
doesn't matter which enol we make?
That's right. Good, except this is a benzene ring, so if you're going to draw it out,
Oh, C6H5 isn't just
you'd have to draw it like this.
I thought
Otherwise, it would have way more hydrogens.
Okay.
If it was just a normal cyclohexene, there would be about twice as many hydrogens as carbons, 2 hydrogens on each. So C6H5 is a phenyl. But the easiest way to write that is just like this for pH. So yeah, the C6H5 here just stands for a phenyl group. All right, so far this is pretty similar to what we saw before. Again, I think it really helps to keep labeling the alpha carbon that's acting like the nucleophile, and it attacked the beta carbon over here. This got attacked, and then this eventually protonated. Now let's talk about what can happen here. Notice that here we have another enolate. Part of the Michael addition is basically to make another enolate. Part of the Michael addition is to make another enolate. That's why you could put the negative charge here or here. Now what can happen to this enolate after this 1,4 addition? Well, there's 3 things that can happen. First of all, this might act like a nucleophile and attack another electrophile. That's something else that we haven't talked about, but is likely to come up on the exam. This could just act like a nucleophile and attack another electrophile if there was another good electrophile in the mix. Now in this case, there aren't really any other great extra electrophiles for this to attack. But sometimes you'll see this just act like a nucleophile.
Like the other carbonyl?
Attack this one over here? Or, sorry, say again?
Like intramolecularly.
You mean attack over here? Yeah. Turns out that that usually doesn't happen. It usually doesn't happen that this alpha carbon over here is going to attack this one. If there was an alpha carbon over here, this would be in a good position to attack here, but this turns out to be a little bit too strained for the alpha carbon that's right next to the beta carbon to attack. But you're getting ahead of ourselves because that's going to be the Robinson annulation in a second. If this had been a good alpha carbon over here, then maybe this would have attacked. But we can talk about that in a second. The only point I wanted to make here is it's possible that this could attack a separate molecule, like a nucleophile. Or if it can't do that, maybe it'll just protonate, which is what we did here. Or if there's nothing for it to steal a proton from, it might just end up with a negative charge. So any of those are possible. If there's a good electrophile around, it might attack that. If there's something that can deprotonate, that's what happened here. Or if neither of those could happen, you might just see it end up with a charge. So that's a little bit more rare. One of the pesky things about this part of the course is sometimes it's hard to know when the reaction is over. So you have to see if there's anything interesting this could do. In this case, all I could do is really deprotonate this. All right, so this was another simple Michael addition, and that didn't give you guys too much trouble. So now let's see how to put all this together with the Robinson annulation.